Can you see my screen? I see my screen. Can anyone hear me? Hello? Okay. Steve, is that for hearing me or seeing my screen? Or both? Can you hear me and can you see my screen? Anyone? Okay, thanks. Yeah, so I will continue from where we left off in the morning. Okay. All right. So, engineering and technology. So, yeah. So we discussed in the initial session. We discussed like several problems, like how you identify a problem, then maybe how you come up with a solution for it. So now that you have a problem and a potential solution, then what what next? Um, so yeah, by the time we get to this stage, it's already assumed when you are ready to actually technically implement your solution, it's assumed you have already gone through the problem discovery stage and then finding like a feasible solution, right? So at that point, we assume you've seen a real problem, you know who experiences the problem and why it matters, uh, and evidence that the problem exists. You have a proposed solution. Some evidence that people might actually value the solution you are coming to propose. So now the next question is the solution you have technically feasible, and feasibility can mean many things, right? So I mean you can't possibly solve everything with technology, even though you can do a lot. So the solution you have, you need to understand, you need to really understand like the implementation details of the solution and know that okay, so this is something if we say we are solving it with technology, we have the available resources, and resources may include maybe third-party services, like other dependencies, and I mean even money, right? If the solution costs like millions of dollars, then your current status or situation that is not feasible for you. So yeah, so you need to understand like the feasibility of the solution before you proceed with implementation. And we saw this before, like a technically impressive system can still fail if it doesn't solve the right problem, or it doesn't work for the intended users, or cannot realistically operate in the region or demographic that was targeted for. So the technology should be selected because it enables the desired outcome, not because it's technically interesting. So yeah, I mean, you don't want to uh, focus on using some cool tech, maybe Golang or Rust or Java. I mean, yeah, all those languages, right? To, I mean, look cool. But what you need to assess is every language has its own strengths and weaknesses. So for the problem you want to solve, you need to consider which language has more resources in the, I mean, like the solution or the context that like you want to solve or you want to try solving. So take AI, for example. AI is like Python is very dominant in the field of AI. So if you want to build something in AI, I mean, many wouldn't expect you to use like other languages or maybe older languages like maybe Lisp or Elixir or like I mean modern languages like even Java has like some good, very good like AI support. But primarily when you say AI, you know that Python has like very high dominance for building like AI stuff. So I mean, so I'm not saying use Python. I don't know what you will be working on. So assess the solution you have and then um, compare it to like whatever tools or technologies you have at your disposal. Make your decision on what you want to use. All right. And so now you have the problem. You need to translate the problem into engineering requirements. So, sorry, is anyone speaking? Okay. So, yeah, you need to translate the problem into engineering requirements. So what that means is, so far, like your problem statement will only describe like the human problem in simple language or English. Now, an uh, engineering needs to also translate that problem statement into system requirement, right? For example, you have maybe a deaf student struggle to follow lectures because spoken information is not always accessible. So now that's the problem statement. What is the technical requirement? What technical solution can solve this problem? So now we go potential requirements. So we know that for deaf students, you want to because they can hear, you want to give like them alternative ways for them to understand like whatever is happening. So you want to capture like spoken audio, then convert like the speech to text or display captions in real time and maintain like a readable text such that it is understandable for the person reading and work with different speakers and also handle like noisy environment. So we can allow lecturers to upload materials that can also go through these same like processes or work on commonly available devices. So, yeah. So once you do this, now you need to also understand that engineering, in its general sense, it's more about trade-offs. And so any decision you make, you'd have to give something up to get another thing. There is almost never a perfect technical solution. Every decision may involve a trade-off. For example, if you want a highly accurate AI model, you will need more computing power, which is very expensive, right? Depending on how high you want it. And a simpler model may be cheaper, but it may be cheaper and faster, but less accurate. To be less accurate. Now, an offline application may provide better reliability, also require more complicated synchronization. If the application is offline, you may want to sync it with what's it called? The server side to, maybe download new content and cache it locally so that the person will need internet to access that data when they come. So all of these are engineering decisions that you have to make depending on the solution that you want to work with. Right? If it's a solution that needs very accurate AI responses or something like that, then you know where would be like a good balance between getting finding cheaper model whilst also maintaining like a good output with rich output. Now, so in engineering, there is something we call like the functional and non-functional requirements. So every system has two main things. So yeah, the system has answered two questions. When engineering a product, we need to describe both functional requirements and non-functional requirements. The functional means what should the system do? So these are functional requirements. So they describe behaviors, capabilities, and operations the system must provide. These are like the things you want your system to do. If I'm a user and I come to your product, what I am seeing or the journey that I am going through is the functional requirement. Without those things, your product doesn't exist. Now, the non-functional requirement is essentially how the system should behave whilst doing the, functional things. And these are, they describe the quality, constraints, and characteristics of the system. Yeah. Yeah. So we'll go through, there are a few examples that we'll go through. So from the problem to the product, right? So you have a problem that's like the real thing that needs to be solved. Now you gather your requirements, your system requirements, and And these requirements are the functional requirements. So what the system must do or be able to do, right? Then you build, so the implementation, so you build and then you test it. And then now once it's built, you have a product, then you put it in users' hands to use. So you can see the non-functional requirement is kind of isolated, as if it's not playing any role here. But without non-functional requirements, your application may not work, right? Not even may. It just won't work with, depending on the specific non-functional requirement that you may fail to do properly. So for non-functional requirements, you have things like performance, reliability, availability, and private security and privacy. So before we go into each of these, does anyone have any questions up to this point or any contribution? Okay. I mean, if you don't have questions, I will find some questions for you. Okay. So, yeah, so look into like what each one of these means, right? So for performance, who can help us with performance as a non-functional requirement? What does it mean? Again, like we did in the morning, I love the fact that a lot of you that I really want us to encourage us to do same now. So I mean, for performance, if you have any idea what it means in the sense of a functional requirement for software, feel free to raise your hand or unmute. Speak. Anyone? Performance. No one. So, yeah. So performance essentially being how quickly and efficiently your products work. If I'm a user and I come on the platform, what experience am I going to get with regards to like the speed, like how things load the on the platform? When I try to search something, how long does it take for me to get a response? In fact, when you go to Google right now and you type something, you instantly get a response. And have you asked yourself how that is being done? So these things will not necessarily uh, count as part of the original problem that Google is solving. But in a way, it exists. It also affects like the overall experience of the users that will come on your platform to use it. Right? So no matter how good we solve your problem, if you take if you don't take non-functional requirements seriously, many users may not be able to enjoy your product. They will just have a bad time on the platform. So yeah, so performance just describes how efficiently the system responds to requests and process work. User experience, performance users experience performance through things like page load time. Right? As I said, if I open your page, how long does it take to load? API response time. I'm not sure if everyone on this call is technical or understand what an API is. So essentially, when you open any application or website, that application is getting information from server that is hosted somewhere. It may be closer to you or not. So depending on where your server is located, that can also uh, impact load time. So if your API response time is poor, then the user will experience bad loading time. You keep your users waiting for longer periods when they try to load the application. Same thing for search speed. So if you have lots of data and you are trying to search through it for something, I mean, if you don't have proper mechanisms in place, like maybe indexing or something, it may take longer to for whatever the user is searching to be returned, right? So that also gives like a bad experience to users on your platform. And image processing time. I'm not sure if anyone has opened a website that like you open the website and then you see a blank screen. Then gradually you see an image gradually loading and building itself on the page, right? So that kind of behavior, it's all part of things that should be handled, like all parts of performance and bottlenecks. And so we have like AI response time, video and audio latency, right? When you have a video on website and you click on it to play, does it lag or is it able to continuously stream without breaking? So all of that are performance issues that needs to be handled. And these are all non-functional requirements. And the next thing is reliability. Anyone wants to try what reliability means in the
Yeah.
context of non-functional requirements? Yeah.
Uh, I think reliability will be about how trustworthy or how rich the content is. For example, if let's say your AI is given, we are building in the space of route intelligence of guiding people from one point to the another point by using Churchill. So from the user point that we started this afternoon, we have realized that most of our information and the output from the model is not quite reliable. So we are trying
Okay.
to be able to fix that subsequent and be able to see. So I think that will come under the reliability part.
Okay. Yeah. So that's great. Anyone else? Anyone else? Uh, any? Let's we see. Are you speaking? This she. We see. Okay. Yeah. So Wilfred, thanks. So your yeah. So it's I think what you described is in the context of AI responses. Yeah. So yeah, AI has. I mean, when you're building with AI and it's not giving accurate response, you can't really rely on it. but in the context of non-functional requirements, I mean, how do I put it? In the context of non-functional requirements, reliability, as you said, when something cannot be trusted, right? So reliability describes the ability of a system to consistently perform correctly over time. But in this case, it's in the context of non-functional requirements, like requirements that doesn't necessarily relate to the problem you are solving, right? So when you look at the AI example you gave, I mean, AI could be the solution to your problem. So that means if you don't use AI, you may not have like a reliability problem, like from like the context you gave, right? So if so if you use AI, that is when like you get like whether like the response of the AI should be reliable or not. But yeah, like the same explanation you gave transfers perfectly to the non-functional requirement in the context of like system design. The non-functional requirements, I mean, reliability in the context of non-functional requirements just describes the ability of a system to consistently perform correctly over time. Right? So imagine a system that helps people schedule accessible transportation. So it works fine during a demo, but occasionally you realize maybe some bookings disappear, you have a duplicate booking created, or a wrong driver receives the request. So, or I mean, the payment is recorded incorrect. So in this case, the system has the required features. It does everything that we want it to do, but users cannot trust it, right? Because the behavior is inconsistent. Not that it doesn't, not that it doesn't work. It may work, but there is too much like inconsistencies. So people cannot fully trust it. And the next thing is availability. Anyone wants to try it? Availability in the context of functional requirements. Ability, anyone?
For availability, can it also be like, let's say, the booking platform that you're talking about, where now this person does not have internet, but then could maybe want to use it as a USSD platform, and then you don't have that available.
Mm,
That's how I'm understanding it.
okay. Yeah, we come to that. Anyone else? Anyone else? I mean, if you don't agree with what Wilfred said, mute yourself. If no one speaks, that means we all agree.
Hello.
Hello.
Hi. Sorry, your name didn't see the.
Yes, so availability means ensuring that users get access to the service that you are providing.
Okay. Good. Yeah. So we have two answers. Does anyone else want to go, or we should?
Yeah. Hello.
Who else? Yeah.
Yeah. So I think availability has to do with how high of a percentage you can make your system resources and functions available to, or functional enough for users to make use of. So, for example, if you build an e-commerce, now I'm talking out of context now. If you build maybe an e-commerce website or something, how high of a percentage can people access whatever they need on your website, and how well does that go for them? I think that's what I understand from my perspective.
Great. Okay. Wait, is that Mauli? Are you the one who just spoke? Or Mauli is a difference?
Yeah, it's Mauli.
Okay, you just okay. Right. So yeah, so we've had three answers. All of them, there are no wrong answers. So from the as you can see, like everyone spoke along the lines of like the product being available for people to use. If I come and I want to use the product, I should get something to use, right? Now, if I don't get anything, that means, your product is not available. And I think Godfred mentioned in the, describe a scenario where maybe your product requires internet and then a person doesn't have like internet connectivity. So do you have a USSD um, version for the person to use, right? So yeah, in the context of availability, that's close. So availability is essentially, uh, I mean, I mean, availability is essentially users being able to access the system when they need it, not necessarily through different channels. Right? So if I deploy my system on web and then I come to the URL and then I just see that the system is down or the page doesn't load. That means your system wasn't available for me to use. And at that point, it doesn't matter if you have a USSD application. At that point, I came to the web, not the USSD. Right? So if I went to the USSD and it worked, I probably wouldn't have noticed the web was down. Not everyone will use USSD. You don't choose for the users. So you have to make sure any channel or platform you decide to provision your products, you should always be available for them to use. Right? So a system can be reliable when operating, but still have poor availability. What that means is you may have intermittent downtime. The system is reliable, all right, but every now and then you are having downtimes and all that. You are having downtimes and people are not able to access your products. And availability is usually expressed as a percentage of time that a service is operational. So when you look at big companies, they all hold themselves to very high standards of availability. Some companies will have like a standard of having maybe 99.9999, about 7 or 8 nines availability. What that means is they will virtually never go down. And Amazon is one of those companies that have like that level of that hold themselves to that level of standard. So that means every single time you visit an Amazon website, you'll get something. It will never go down. Okay. The next non-functional requirement is security. Does anyone wants to try? Security, as the name implies, many people know. So does anyone want to give it a shot? Security in the context of non-functional requirements. Who wants to go?
Yeah, hello, sir.
Yeah, go for it.
I think with security, it will come upon the point where is it secure? Is it following data requirements policies? What are you storing? And is it relevant towards the problem that you are solving?
Great. Yes. Anyone else? You want more perspective? Yeah, Maoli.
Okay. So for security in particular, I think a few things we'll have to consider a few things in terms of security, including integrity. So is the information that is outsourced on your platform or your solution kept as it is, or does it maintain its full integrity from the source to the destination? I think you can also look at a few something like availability as well. So is could we access your software in a secure manner? Is it available to users in a secure manner? Are there any middlemen who would be stealing or taking advantage of people in your system and all that? So I think that's what I get from security.
Yeah. Any other person? Okay. Great. Yeah. So I mean, as you all said, security is essential in protecting the things you have, your product. What Maulu described is more in the context of data in motion, right? If, if your front end or or your mobile app or whatever is sending some data, your backend, and someone intercepts that data and then manipulate it, which I think he mentioned that's like data integrity, right? So if that happens, then the the integrity of the data is compromised. So you can't really trust that data. So data in motion can also have like security risk. Uh, well, that's why I say we need more perspective. Right? You can see my example here. I don't have that as a part, but that is also a very valid security concern. So the security is essentially about protecting systems, accounts, data, which will fall under, like what Molly said, will fall under uh, transactions, infrastructure, and users. So protecting all these, let's say, components or parts of your system. So from unauthorized access, you're protecting them from unauthorized access, misuse, or attack. There are several important concepts we'll talk about in the next slide. So there are various security mechanisms. I mean, very standard ones that every application that, let's say, collects some sort of data from people should have, because you need to ensure that data is protected and not falling in the hands of bad actors. So the first thing is authentication, right? Then we have authorization, encryption, access control, and audit logging. So taking authentication, who can help us what that means for an application? Authentication. So authentication essentially means you need to, when you visit any website, I mean, not any website, but most social media apps you realize what you do is you log in, or if you have logged in before, most modern applications will remember that you have already logged in and they are able to persist your session for longer periods. So what the process you are doing by logging in is what authentication is. That means someone wants to access some data, but you need to know that this person is who they say they are, right? So they need to provide credentials that they set or they agreed with the system. So before you are logging, you have to create an account. You give the system a password to keep. Then when you want to log in, you come back with that password and make your email or username. And then the system will check and see that, okay, yeah, so this data belongs to this person. Then they let you in. Authorization. Authorization, does anyone want to try?
Okay, so
Yeah.
Yeah, please with the authorization, it deals with let me say after authenticating, like the user have to let me say has a limit or some let me say the user is allowed to do um just a specified thing, yeah, not the entire let me say the entire source, but just that yes, the user is required to let me say make some specific tasks to do some specific tasks. That's what the
Yeah.
let me say the designer has authorized the person to do.
Yeah. Right. Anyone else? Does anyone else want to try? Okay. Yeah. So as Alexis said, wait, someone. So as Alexis said, authorization is about access controls and privileges that the user that has logged in has. So remember, you have an application that a lot of users have created their accounts. And now one user is logging in. How do you ensure that the user logging in only sees things that belongs to them? Right. So that if Alexis logs into the product that you created, they are not going to see Godfred's information or Godfred's name with the information in their account. So that is what authorization is about. Essentially, access control. So you define create permissions. That's okay. This user that has created an account can do this and this and that on the platform. Any other thing that they try to do, you don't allow them to do it. If you, I mean, for those of you who are students or even, yeah, I mean, for those of you who are students, if you, I don't know if anyone has tried, if you try to, if you're a student, you can only have access student portal, you can't go to a staff portal with your student credentials and try to log in. If that works for you, then you know that there is a problem because you are not a staff. Your credentials would give you limited access where you belong, and you should only see what belongs to you or what has you have been authorized to see, not everything. So the next thing is encryption. Encryption. Any anyone want to try?
Okay, so
Okay.
please, I'll say that is the it's like you are dismantling the message. Yeah, so that even if a third person, let me say someone gets even the message from the person won't be able to access the message. But as for the person, the final user you want the message to go to, the person will also decrypt it. Yeah. So as for the person, he will get the exact message you are sending. But any middle person that will comes into the, let me say, the in between you guys, the person won't get access to the message.
Mhm. Good. Good. Yeah. So that's correct. So encryption is essentially making meaningful things look useless or not meaningful. So have text or a message gets encrypted. You can encrypt it and then just give it to you. You can't do anything with it. But whoever that message was intended for will have what it takes to reverse the encryption, which is called decryption. Decrypt that message back to its original text so that they can read it. So software systems use encryption in messaging channels. So if one system is sending a message to another system, in some cases they may encrypt, they may agree on specific encryption uh, mechanism or encryption algorithm, and they both have what it takes to decrypt whatever message they send between themselves. So if you're a third party and you intercept that message, you don't have what is required to decrypt that text. So that information is essentially useless to you, the middleman. So only who it is intended for can decrypt it. So that's what encryption means. The security mechanism. Okay. Access control. Um, if anyone wants to try.
Okay, so please, I'll say that it's like it's more of the authorization. Yeah. So as for this one, it's controls. Let me say the person who will get access to the let me see the project or the app. Yeah, and
Okay.
and what the person needs can do and what the person can do.
Okay.
I think that's
Yeah.
what I can say.
Good.
Yeah,
Yes.
hello.
That's right. Yeah. Hello.
Yeah, I also
Hello.
wanted to add up that
Go for it.
yeah, the access control tool also could also mean that um, Does also the user has permissions to delete their own data? Is the app having access to location? And does the user has control with be able to disable and all that? That's what I'm thinking.
Okay. Yeah, I mean, yeah, that's so access control is essentially, like you said, it's quite similar to authorization, right? Access control essentially means like having very strict permissions attached to like users. So if you remember the authorization, I mentioned something about people having to see what they are authorized to see. But then, how do you tell that this person will be able to see this and that? Right. So the access control mechanisms is essentially like that process where like you will assign certain permissions. Otherwise, you say like scopes. Right? People who access your product is to be able to see just a specific scope, right? Specific scope, or to be able to perform very scoped operations. So they can't do everything, they can't see everything. So these permissions are your access control list. So in certain products, you see something called ACL, which is the full meaning of access control list, which essentially means like the same thing, that permissions, rules and permissions that are assigned to these users on the platform, right? So yeah, thanks. You're both right. And the last thing is audit login. Audit login. If anyone wants to try, or even login. So if the audit is making it confusing, just login. Does anyone know what login means? Yeah.
Okay. With the login, it's like recording or jotting down everything that runs through the program. Yeah, every once the app click, yeah, it will record it. That's for the login. Yeah. So with the audit login, I can say that it's like it's a check that it checks, let me say, the things that run through the app or the program.
It's a what?
Sometimes I'm saying, okay,
The audit log. I didn't get the word.
the audit login, it's like it checks the running of the program. Yeah, it checks the running of the program from time to time. Yeah. So so it keeps let me say the records of the app and everything. So whenever the user wants it, the user is able to get access to the history and stuff, so that in case of any inconvenience, yeah.
Oh, any other contributions?
Hello, sir. Please, I'd like to add that
Right.
to what.
Okay.
So
The name is it Ernestina? Yeah, go ahead.
basically, so the audit login is like a system that keeps track, not to keep track or records of whatever activity that is going to take place in the system. That in case of any
Okay.
unforeseen circumstance or anything that happens, they will be able to track whatever activity that has happened or whatever thing that has been going on in the system.
Okay. Good. Yeah, that's right. Yeah. So as the all said, so audit login or login is essentially recording activities that is happening in your application. anything that happens, we want to log it. So logging in general, will have like several benefits. Some can be like it's very essential in debugging. If something bad happens in your application, and you have good login mechanism in place, you'll be able to trace and know what's happened or what went wrong before your application failed or crashed. Now, audit login, I mean, the word audit just adds to login. What auditing means is, I mean, it's let's say a way or an accountability mechanism in a way, right? So we want to be able to hold people accountable for their actions on the platform. So in that sense, anything anyone do or anyone does on the platform, it is recorded that it's someone, yeah, um, anything anyone does on the platform is recorded. If I log in and I perform any activity, it's recorded that, okay, Benjamin did this. Now, in the future, if something goes wrong and they go through these audit logs and they realize that at the time that I performed a certain activity correlates with the time that that bad thing happened, and maybe any other person didn't log into the system in that period, then you know who caused it, right? Now, in the context of what's it called? So these are all like security mechanisms, which is falls under non-functional requirements. The context of this hackathon, depending on the system you decide to build, you may want to implement audit logging to also like keep track of certain things happening in the product. Okay. So the next thing, privacy. So yeah, privacy. So before, I mean, okay, let's go through it. So privacy is essentially about relationship between user and their information. So it's very critical because privacy breach can cause very severe damage to the victims involved. Sometimes depending on their profile or status, like someone like a high profile person gets a breach of privacy, then you know that's dangerous because one, this person is high profile, maybe probably known. I mean, if the person is politically affiliated, then you know that also becomes, a problem. So privacy is a very important thing to consider, right? And even when the person has, it's not a high profile person, it is still very important to make sure that people's information, or there is something we call PII, which means personally identifiable information. So these are information that can be used to identify like a person, right? So some an example may be in this country, everyone has a Ghana card. Your Ghana card number is a personally identifiable information. If I have your Ghana card number and I have like a system that can resolve that Ghana card number, I will be able to know all your information, your first name, your last name, this and that, your student ID number. For example, all these information are very sensitive. So if you are building a product for the student community, and you are collecting their student ID number or anything that directly ties to the identity of the person creating the account, then you have a big responsibility to make sure that information does not leak or it doesn't get compromised. So when you are building products, always be transparent about how you plan to use sensitive data, right? So you don't, example, if I visit any platform that instantly asks me to provide Ghana card number, if it is not a government service that I think I truly need, then all of a sudden I see you asking me to upload my Ghana card or provide my Ghana card number, then that turns me off instantly, and I'm not going to do it, right? So it's the same way. Maybe you may have a good reason for taking that data. So you need to anticipate that people are skeptical about providing such information, and you want to explain to them why you are taking that information that time and you intend to use it for. Okay. Next thing is accessibility, which is very important for this hackathon because the whole theme for the hackathon is to provide solutions that are more accessible for the deaf community. The accessibility is um, the degree to which a product, service, environment, or technology can be accessed and accessed and used by people with different ability and circumstances. In simpler terms, it just means removing barriers that prevent people from using something, right? So it doesn't necessarily have to be software. If, if there are barriers for anyone to use anything, then that thing is not accessible. So still an accessibility. For example, like maybe you have uh, image service, image service that requires reading, clicking tiny buttons, completing a complicated form, listening to audio instructions, having a fast internet connection. This may work for some users or many users, but it still creates barriers for certain groups of users. Take tiny buttons, design choice, tiny buttons. Then when you check the potential barrier, it may be difficult to use for people with motor difficulties, like people that are not able to move or turn or something. So if something is far from them and they can't, and it's also small, then they can't see it and they find it difficult to adjust or use that product. Right? Then you have images containing important text. Then blind or low vision users may have a challenge. We have a challenge using it. Then audio only instructions. If you have a product that has only audio instructions, you know that people that are deaf or hard of hearing won't be able to benefit from it. Right? Won't be able to benefit from it. Then, complicated language. you have a product that has complicated language, then people with low literacy also won't benefit from it because they won't understand. And yeah, English content, English only content. So English only content. You have a product that has only English, and then your target users or target market for people in maybe villages or less developed uh, places, then or people that don't have like access to education where they can learn like English, then you may want to provide alternative uh, language for them to properly understand what your solution is about. Yeah, I mean, large data requirements. I mean, users with expensive or limited data also won't be able to benefit, right? These days, when you open any application, instantly you have your data swallowed and you have to buy another data. So all these things affect uh, how accessible our application will be. We need to take all of these into consideration, especially the um, ones for low vision users, deaf, low literacy. These are people that are underserved. And if you are building a product or a solution for them to use, you definitely need to consider these things. Still on accessibility, so for screen reader user, the application may need semantic HTML, uh, proper labels, logical navigation, and then keyboard accessibility and meaningful error messages. HTML is essentially using HTML tags that explicitly describes the meaning and purpose of the content they contain, rather than just how it looks. When you look at the HTML tags, there are a few ones that are like that have special purpose that you may want to use, and they all have like ability attributes that you can pass to it, and then you have like devices automatically adapting to it to make your product more accessible. So for users with hearing impairments, we also want to provide captions, transcripts, or visual alerts for them to also understand what your product is about or what you're trying to communicate. Okay. So for users with motor impairment, that's users that are not able to maybe move or adjust properly, adjust their body very well. You want to have large controls, like you make things large enough for them to be able to like easily access it. Right? If someone has a motor impairment, if they are raising their hand to maybe tap on a button, and the button is very small, they will find it hard to aim at the button properly. And so you want to make things large enough for them to not miss what they are targeting or what they want to target. And you may also provide alternative input methods for people like this, right? So if the person has to maybe get up to do something or move their body to do something, you can have like something that uses a voice command or something. They just maybe have to speak or have to do something else that doesn't require them to engage too many parts of their body or wherever they have like a problem with. And also reduced precision requirements. Reduced precision requirements. So I believe that would also mean like how do I put it? It's like how I described with a large button. So you don't want, so maybe you have like a box that, okay, if this user taps on this box, this should happen, right? But then, yeah, the user didn't exactly touch the center of the box, but they touch at the, maybe some part of the edges, right? So you still want to be able to like accept that as an input, do what the person intended to do. So that uh, is like reduce precision requirements. So you don't require the person maybe to tap exactly at the center of the box for something to happen. Even if they tap on the edges or somewhere a bit close to where their clothing is, they should be able to um, get what they want. Now, for users with low literacy, so want to use simpler languages, you want to use simpler language, um, visual instruction, and local language interactions. Right? So, yeah, someone with um, low literacy, like, yeah, like you want the language to be simpler for them, simpler enough for them to understand. You want to have visual instructions, local language interactions, like translations or something, so that they're able to uh, efficiently uh, communicate or use your product. Any questions with this point? Any questions? Okay. Mhm. Mhm. Okay. Apologies. Um, okay. Yeah. So architecture. What what is software architecture? So this is another important thing that you want to consider when you are building a product. Right? Because what architecture you decide on and make or unmake your products. If you take an architecture that is um, difficult to manage, you may end up locking yourself in a place that will you realize the only way out is to rebuild everything. However, if you are thoughtful about architecture in the beginning and you uh, and you come up with a good architecture, you can like have like a product that really evolves without breaking anything. Right? Okay, so software architecture is how major parts of the system uh, it's how major parts of the system are. Right? Yeah, so it's how like major parts of the system is organized and how they interact with each other. So consider like a simple application with a user that has a mobile phone or uses a web app, like that open their browser. What any interactions they make on the mobile phone or the browser go through certain server, which I mentioned earlier, they communicate through API, right? Which means like application programming interface. So it's a communication medium that like that uh, software systems use to share data, transfer data. Then your backend is also usually communicating with a database, right? Also usually communicating with a database. So your mobile app or front end will send data to the backend. And the backend will forward that data to the database. Right? So let's look at like the responsibilities for each of these components that we have. Okay, so the front end handles presentation. So presentation in the sense that what does the user see when they visit your app? What does the user see when they visit your app? So that's what you are presenting to the user. Mind you, your presentation layer doesn't have to be a mobile app or a React web app. It can be a simple console application. You just test your proof of concept. When you are confident everything works, you can build a good UI and connect to the same backend that you have. Right? So when you're able to reason about software like based systems of systems or components that are interconnected, it makes things simple because now you tend to view things from the point of like uh, how do I put it? Like a puzzle, right? Where like you everything everything fits into something, then they all come together uh, to form a full product that provides value. And the backend, on the other hand, handles business rules, authentication, processing requests, and communicating with other systems. So what we mean by business rules is things, uh, essentially your functional requirements, right? Your backend will handle a huge chunk of your functional requirements. So if you want the user to be able to log in, okay, then you need to have authentication in your backend. When the user goes to log in and they enter their credentials, there is something on the backend that is taking that credentials and then verifying it against the database if that credential exists and it's correct. Right? Then processing requests. So yeah, the backend is also um, responsible to process requests. Right? So you may have multiple users that are sending requests. Um, many requests at the same time or like varying times, how does your backend, how do you make sure like your backend is able to handle all of these requests properly? So all of these are responsibilities of the backend and also communicating with other systems. So yeah, usually when you build software, you are not building everything from scratch. People have laid certain foundations, and then you are building on top of that foundation. An example is the programming language you use. You didn't create that yourself. Some other people spend years to work on that, and then you are using it. Right? So the same way, there are other services that already exist, like the AI models you probably plan to use for your product. Were not created by you, also created by other people, and you plan to make use of it. So you are going to communicate with all of these systems that are outside the boundaries of your own system. So your choice of database entirely depends on the requirement of your product. Essentially, like I mean, with databases, we have like two main ones: the relational and non-relational. The relational database being SQLs that we mostly use, the Postgres, the MySQL, Oracle, and all those things. And then the non-relational database, non-relational database is in database that are usually like documents. Please give me a moment. Sorry. Yeah, sorry. Okay, so yeah, your choice of database. So we have like a non-relational database too, which essentially, I mean, there are a few of them. I usually call them NoSQL. So we have the SQL and the NoSQL. NoSQL are usually the non-relational database. So they do not rely on relationships, right? So we have examples like the what's it called, MongoDB, and all of these like documents-based databases or yeah, these document-based databases. So for every software, yeah, we have various layers. As I showed in the previous slides, so the presentation layer, the backend, and then the database. Nothing new here. And also with your database, I mean, it doesn't necessarily even have to be an actual database, right? It can be a simple file that you write something into. So a database is essentially like a persistence layer. So anything that is able to persist data or the data coming into your application, it's fine as long as it works. So in the beginning, if you don't want to go through the hassle of setting up a database and all that, you want to just maybe write a small function that will write something to a file to just validate your proof of concept. That is fine. You just have to build it in a way that when you're ready to go to market and go live, you can easily swap that file-based, persistence with an actual database, right? So, which is why I was saying first you have to reason about software as a group of components that talk to each other. Right? So, if you have different components, that means you can take out one component without affecting another component. You can replace one component without affecting other components. Right. So if you have maybe software, you think about authentication as its own component. You think about um, like what's it called? Like other things, registration and all those things as their own components. Right. No, no, no. Yeah. Right. Yeah, you think of things as independent components. You are able to build a system that can really evolve without breaking things. Okay, so we have monolith versus microservices as software architecture. Um, Anyone tell us what the difference is? We are very close to getting to the end of the slides. I think we have 2 more slides. Yeah, can anyone share like the idea of what they think these two mean, monolith and microservice? The microservice is already a little bit described here. Monolith, who can um, tell us something about the monolith? And also, okay, sorry, Mauli.
Yeah.
So sorry,
So
I'm not sure how long you raised your hand for. Yes,
no, I just raised my hand actually.
okay.
Yeah, so the monolith, I believe, is a simple architecture which involves a backend and a front end, and it's more linear in its how it's connected. You have the backend connecting to the front, um, and all services go from one particular point to the other. It's linear flow of data and
Okay.
stuff in that respect.
Okay.
But for the microservices, it takes various services, various parts of maybe a system, and manages them as separate services. So a microservice maybe for an e-commerce website where you have a separate service managing the payment side. You have a separate service managing the customer feedback, all that. So they are basically isolated parts that have been connected together.
Excellent. Okay. Any other person? Can see there is something in the chat. Oh, Robert, sorry about that. Any other contribution? What a monolith and a microservice are? No one else wants to try? Okay. So, as he said, microservice are more of distributed in nature, right? You Microservices require like we have services like independent services that talk to each other, but they are all independently deployed, right? So some of the features of a microservice is, they have deployment complexity because you have to deploy different services independently. And also, when services talk to each other, you're essentially incurring network latency. What latency means is like how fast your what's it called, your requests go through or your requests are handled. Right? That's latency. So if you have a high latency, that means things are slow. Latency essentially means like if you have a high latency, that means like things take time to get processed. You have low latency, that means things are processed fast. So latency essentially means delay, right? So a delay in uh, processing requests. And microservices have distributed failures. So yeah, because they are all deployed independently. When something fails, it may not necessarily take everything down, but anything that depends on that thing that failed will also have like challenges, also feel when they try to interact with that thing. And then, yeah, as I said, it has deployment complexity and then monitoring requirements. So because you have multiple services spread across your different servers, you want to have very good monitoring and be able to know what is happening in all of these systems and if something is going wrong. And as you can see, for this hackathon, you have no business doing microservice. Please keep it simple. Um, yeah. So yeah, a monolith on the other hand is uh, like what's it called? Most of my, like he said, you have everything in one single deployment, right? And you have everything sitting in that. Once you deploy it, everything goes. Like you deploy everything. What that means is if something goes down or if something fails, it takes down your entire application. Your entire application fails. Right? If you have like an error in a monolith, you know that like your entire application is going to crash because something somewhere that is not related to all the other things failed. Right? Okay. So the next thing, like APIs, I have mentioned APIs a few times. How software communicate. An API provides a structured way for software systems to communicate. For example, you have a mobile app. When you open your mobile app, you see some things being loaded. These things being loaded are fetched from the backend. And the mechanism used to fetch is called a GET request, right? So there are several mechanisms or operations you can apply on an API. We have one called the GET request, another called POST request, which means creating something, and then another called PUT request, right? Which means updating something. There are several others, like there are more. There are more like we call them HTTP verbs. So there are more of them, but these are the very common three that you may be interacting with. So yeah, so your mobile app will send a request through like the API to the backend, and then the backend will receive the request. It knows which database to go to. It knows which information to read It goes into the database, it takes that information, and then it returns that information to the user, right? So it takes the user's information and it goes back to the mobile app and presents it to the user. So that's the flow or the journey a request goes through. This, yeah. So third-party dependencies. So I didn't have like more content on this, but I have touched on this in a way previously when I mentioned you not being the creator of whatever you are using or everything you are using. Your language, the programming language you are using was created by someone. You use other services that was also created by some people. So all of these are considered like third-party dependency, of course, minus the language, the programming language. I mean, in the sense of third-party dependencies, I don't think the language you are using is counted as a yeah. So any other service that you are using to achieve your functional requirement or your goal, essentially a third party, and you always want to minimize. You always want to minimize your dependency on third parties if you think they are not necessary, right? So if you have a very strong reason to use a certain dependency, then yeah, so something like the AI dependency. If you are building a product that requires AI, then yeah, you should definitely use AI, right? But other things, um, that's so something like maybe validation, you want to validate user inputs. These are some of the validations are quite simple or basic that you can write yourself and you may not necessarily need to add a dependency to handle that, right? So yeah, these are some of the things we need to pay attention to. Um, sorry, guys, you give me a minute. I have to give something to someone real quick. Just 1 minute. Yeah, sorry, I'm back. If I had in front of someone to give my key to the person. Okay, so yeah, so dependencies. So your software will always depend on other softwares to achieve the functional requirements or to solve the problem that you want to solve. So it's, I mean, up to you to look through what you have available to your disposal and decide on which of these dependencies make sense to your product or what you are trying to build. Then you go ahead and integrate that. Okay, so this, I believe, yeah, this is the last slide. Um, for being here. If you have any questions or contributions, feel free to unmute or raise your hand and we address. Yeah, Pius. Pius.
Hello, please can you hear me? Am I audible?
Yes, please. I can hear you.
Yeah. Please, I'm Pius from UNED. So we are currently writing exams and participating in the online section is very difficult for us. So we wish there's a way we could later review the learning material so that we follow along the process.
Okay.
So if
Yeah,
it is anywhere, maybe on Google, yeah, you can share the link with us. We later review it.
absolutely.
Tomorrow, for instance, we might not be able to join the morning session.
Okay. Okay, that's totally fine. Yes, I'll make the slides available to the organizers to share with you. Yeah, so don't worry, you
Okay.
get the slides. Any other plans, questions, or contributions? We'll dedicate the next 6 minutes to answering like questions, contributions. The remaining time for closing remarks. Hello? Again. Anyone hear me? My network. Okay. Okay, cool. Yeah, my network dropped. So I was saying we can dedicate the next maybe 5 minutes or more like to address concerns or questions or contributions and use the next few minutes to uh, give any announcements or anything from the organizers. So any questions?
Okay, I guess there are no questions or concerns. So, all right. So, thank you, Mr. Ben, again for another insightful session. I hope the teams found this useful with respect to their various projects. Ultimately, these sessions are aimed at helping you come up with a better project. Tomorrow would continue the session. Tomorrow's session would be on computer vision and agentic AI. Again, similar to today, we'll have 2 sessions, morning and evening. And as you've noticed today, the sessions are complementary, not repeated. So what you learn in the morning session would be different from what you would learn in the evening session. However, if you cannot make it, please check the website for the slides as well as recordings for the meetings. The link for the morning session remains the same as the one you used in the morning today. Same for the evening. So in the absence of any other concerns, I think I'll give another 30 seconds. And if there are none, we can call it a day and then we reconvene tomorrow. Okay, none. All right. So thank you all very much for your time and attention. Mr. Ben, thank you very much. I think I've said a lot of thank yous to you. So teams, don't worry. This is not the last time you would hear from Mr. Benjamin. Teams who make it to the next stage of the hackathon would have other opportunities to meet with him. So till then, or rather till tomorrow, do have a lovely evening. Bye.
Bye.
Bye.